we're going to start exploring two different integration methods. The first one is going to be integration by substitution. Then in a later lesson, we're going to do integration by parts. We're going to begin with integration by substitution, and this method is what we're going to use to integrate or to find the antiderivative of functions that are the product of a differentiation using chain rule. So in order to use the substitution method, it is important that we have functions of the form f of g of x times the derivative of g of x. We should be able to identify a product where one of the functions in the product is a composition of two functions, f and g, and the second element or the second function in that product has to be the derivative of the inner function in the initial composition. So how will substitution work? We need to start by defining a new variable. Usually we're going to use the letter u to define that variable. And that variable is going to be the function that is inside of the composition. So we're going to define u as g of x. In that case, the derivative of u with respect to x is going to be equal to the derivative of g. So what do we get from here? We get that I'm going to have du is going to be g dash of x dx. Now the original function is this one. So when I want to integrate this, the integral of f of g of x times g dash of x with respect to x is going to be, after I do the substitution, is going to be the integral of f of u times g dash of x times dx. And here, by taking the derivative of u, I discovered that g dash of x times dx is going to be du. So this simplifies the integral to a point where I can simply refer to the antiderivatives of familiar functions that I have. For example, if I have access to an integral table, I can go and check to see what the integral is, or if it is a polynomial, then I can use the power rule to integrate. The point is that by doing the process of substitution, I have simplified my integral to a more basic function. Our first example is the integral of 2e to the power of 2x with respect to x. So what I notice here is that e to the power of 2x is a composition where the internal function is 2x and the outside function is e power x. But the derivative of 2x is 2, and that is present also in the integral. So that means I can solve this integral using the method of substitution. So I'm going to do that by defining the function u, or the variable u, as 2x, which is the internal function in that composition. And then I'm going to take the derivative of u, so that's going to be du with respect to x is going to be 2, and I get du is going to be 2 times dx. Now I'm going to do the substitution, meaning I get the integral of e to the power of, but instead of substituting 2x, I'm going to substitute u. And instead of writing 2 dx, I'm going to substitute 2 dx with du. So that's going to be du. Now the integral of e to the power of u with respect to u is going to be e to the power of u plus a constant of integration c. Then the original function was in terms of x. So at this point, I should go back and write my final answer also in terms of x. So that's going to be e to the power of, substituting back the u, 2x plus c. In our next example, we have the integral of 1 over 2x plus 1 with respect to x. Now we can identify that there is a composition here. It's 1 over x in composition with the linear function 2x plus 1. However, we notice that the derivative of 2x plus 1 is 2, and that derivative is not here. So in situations like this one, where we can't complete the derivative because there is a number missing, we can do that. We can multiply the top by 2, and then we can divide also by 2 so that my integral is not altered in value. And it is like multiplying by 1. But now what I see is that my integral can be rewritten in terms of a variable u that I can define as 2x plus 1, and I can calculate its derivative, which is 2, and I can find du is going to be 2 times dx. So what I know now is that I can group these 2 with dx to get du, and this bottom will become u. So my integral is 1 over u du. And now I know that the integral of 1 over u du is going to be ln of u. So this is equal to 1/2 ln of u plus the integration constant. Now I will go back to x. So I substitute back ln of 2x plus 1 plus our constant of integration. Let's do one more example. In this case, we have an exam style question where we have find the integral of 6x squared times e to the power of x power 3 plus 8 with respect to x, and then using that information find the value of f of x, given that the derivative of f is given by 6x squared e to the power of x power 3 plus 8, and the function f at minus 2 is equal to 5. So the first part, we can do the integral with the method of substitution, because we can see that the composition is e to the power of x power 3 plus 8, and x squared is part of the derivative of x power 3 plus 8. So substitution would be the best chance for us to do this integration. So what I'm going to do is I'm going to take that 6 and I'm going to split it in 3 times 2. I'm going to leave the 2 outside and the 3 inside, having 3x squared, and then e to the power of x power 3 plus 8 with respect to x. This way, the derivative of x power 3, which is 3x squared, is explicitly seen in the integral. Now what I want to do next is to substitute. So I'm going to define the variable u as x to the power of 3 plus 8. I'm going to differentiate it, and I'm going to find the value of the differential du, and that is 3x power 2 dx. Now that I have that, I can proceed with the substitution. So this is going to be 2 times the integral of e to the power of u times du. And this is going to be equal to 2 e to the power of u plus our integration constant. I'm going to substitute back the value of u. So this is 2 e to the power of x power 3 plus 8 plus the integration constant c. Now for b, find the function given that the derivative is equal to 6x squared e to the power of x power 3 plus 8. Notice how this function is the exact function that we had before. Therefore, we're going to know that f of x is going to be the result of the integral that we just did. So I'm going to write it. F of x is going to be 2 e to the power of x power 3 plus 8 plus the constant of integration c. Now they are providing us with additional information, and that is that f of minus 2 is equal to 5. What is that for? This is information that's going to help us identify the value of c. So we're going to substitute that value into the function. So we're going to say f of minus 2 is going to be 2e to the power of minus 2 power 3 plus 8 plus c, and that has to be equal to 5. That is 2e to the power of minus 2 cubed, that's minus 8, plus 8 is 0, plus c equals to 5. E to the power of 0 is 1, so 2 times 1 is 2. That means c is equal to 5 minus 2. So c is equal to 3. So the final value for the function is going to be f of x is equal to 2e to the power of x power 3 plus 8 plus 3. And this is the final answer. The final example is let f dash of x equal to x divided by the square root of x squared plus 1, and given that f of 0 is equal to 7, find the value of the function. So what we want to do is build the function f of x through the integration of the function x over the square root of x squared plus 1 with respect to x. Now, before we do that, we can recognize that this is a composition. This is a composition of the function square root composition x squared plus 1. And additional to that, x is part of the derivative of x squared plus 1. So I'm going to define the variable u as x squared plus 1, so that when I differentiate it, the differential of u is going to be equal to 2x dx. Now, as you can see, my original integral only has x dx, not 2x dx. So what we can do to complete the derivative is to multiply this by 2. But also, since we're multiplying by 2, we need to divide by 2. We can't do one operation without balancing out so that the value of the integral doesn't change. And then we're going to proceed with the substitution. So this is going to be 1/2 the integral of 1 over the square root of, and in the bottom we have x squared plus 1, and that is u. So this is 1 over the square root of u. And then 2x dx can be substituted with du. Now, I don't know the integral of 1 over root of u, but I can rewrite this integral as a power of u by taking a fractional exponent. I can say u to the power of minus 1/2 du. And I can integrate this using the power rule. So that's going to be 1/2 u to the power of minus 1/2 plus 1 divided by the exponent, minus 1/2 plus 1 plus the integration constant c. This is going to be 1/2 times u to the power of 1/2 divided by 1/2 plus c, and 1/2 will cancel with 1/2, and this is the square root of u plus c, which I can substitute back, and we get f of x as the square root of x squared plus 1 plus c. Now we need to find the final answer for the function, which we can find by using the initial condition that they gave us. They told us that f of 0 has to be equal to 7. So we are going to substitute f of 0, and that's going to be the square root of 0 plus 1 plus c has to be equal to 7. So since this is 1 plus c is 7, c has to be 6. So the function f of x is given by the square root of x squared plus 1 plus 6.